Thank you for joining us. Our topic this afternoon is CNC Programming Made Easy with Manual Guide I, Conversational Programming, Part 3, Creating a Basic Milling Program. Without particular knowledge of G-code programming, it is possible to generate part programs on the shop floor by answering simple questions. FANUC's Manual Guide I, Conversational Programming provides this capability for milling, turning, and mill turn centers with FANUC CNCs. Part 1 in the series gave an overview of the functionality of Manual Guide I. Part 2 built on that introduction by reviewing the entire progression of creating a basic turning program with Manual Guide I. Today is Part 3. We'll do the same for a basic milling program. Our presenter this afternoon is Jody Michaels. As End-User Account Manager for FANUC FA America, Jody Michaels' focus is on servicing and supporting end users to maximize their productivity with use of FANUC CNCs. Jody has 35 years' experience in the machine tool industry with various positions in sales, support, automotive applications, and training at machine tool builders, end users, and CNC suppliers. He is a true expert on CNC programming and the functionality, setup, and use of Manual Guide I. As we listen to Jody during the presentation, please feel free to share your questions with us by typing them in the questions pane on your control panel. He will answer those questions at the end of the presentation. And keep in mind, this webinar is being recorded, so you will be able to view the entire program online later. So again, thanks for taking time to be with us for the live program. Here's Jody.
Thanks, Mark, for that nice presentation for me. And as you said, today we're creating a basic milling program. And what we're going to do today is we're going to pretend, and here's the part first. We're going to show the part that we're going to do. We're going to face it. We're going to drill it. We're going to tap it. We're going to pocket. We're going to contour the part. And this shows a representation of what we're going to do. But first, what we're going to do is we're going to do a little bit of review of what we did on the first two. So we're going to pretend today that the machine that we're going to start working on is a machine just like you would get, where it would not have any fixed forms and tool data. So what we're going to do first, we're going to go through the process of loading the fixed forms into the control and then also our tool data, just like you would if you were getting a machine that was fresh out of the box and you just got it installed. So again, this is the part that we're going to do. We're going to drill and tap 10 holes on the face. We're going to do a pocket, and then we're going to mill around the contour. So we're going to do almost everything that the milling cycles have to offer. So at this point, we're going to start. And what we're going to do, we're going to go into NC Guide, just like we did before. And as I said, what we're going to do first, we're going to go into the edit mode. And typically, when we go into the edit mode, the first screen that you would see would be this, where we'd start a new program. But as I said, what we're going to do, we're going to introduce our fixed forms. So if you go to the right arrow key 4 times, and we get to a setting soft key. And today, I've talked to several people since we've done the first two, and they said sometimes I do this too quickly. So I'm going to try to be more leisurely in when I'm clicking on the different buttons so that you see the buttons that I press each time. So right now we press the settings soft key, and it brings you into this screen, register fixed form sentence for milling. And we select that, and it takes you into this screen. And see, it still shows the fixed forms that I had in there. But what we're going to do, we're going to delete this. Because if you press this, and this is a note of caution, once you get your fixed forms in there, you have this standard soft key. If you press that, so it comes up and says, are you sure current is overridden by standard? You press yes, and what that does, it deletes all the fixed forms. So don't press that button when you're using Manual Guide I in your fixed form. And now what we're going to do, we're going to input them back in. We're going to press input. And What it does, it goes and finds any files on your memory card that are related to either fixed forms or tool data. And there's only 2 files. So we select the fixedform.dat, which, as we mentioned before, this is only a text file. This is something that you can edit if you want on your own. But we don't want to open that right now. All we want to do is just input it into our machine. We press input. And it says, are you sure the current is overridden by input? Yes. And it's read complete. Then we close it. And then we have our fixed forms back. We have Form 1, Form 2, Form 3. I don't have any in Form 4, and Form 5 is our end of program. So it's just that easy to import our fixed forms into that. And this is something that either your dealer, your builder, or FANUC itself can help you with these. Okay? Then to get out of that, you go to Menu, Cancel, and that takes us right back to where we were before. Now we're going to go through the process of inputting the tool offset. We go into tool offsets. And see, at this point there is some tool data, but if you arrow over to tool data, this shows the list of tools that we currently have. But at this point, if we press right shift twice, it brings these 2 soft keys, output and input. If you want to bring the information in, you press input, arrow down to the tool tooldb.dat file, and that's your tool data file, tool data backup file. You press input, and see it reads through. It's a little different from the tool data. It doesn't give you 2 buttons where you have to push it twice, only one. And then you close it. And see, now we have all of our tool data in our machine, exactly the way I want. And then also, as we said, we also have our fixed form. We select this. We've got all the fixed forms that we need to help us build a program. So this is important that you know how to do this. So at this point, like I said, to Menu, Cancel. Now go left shift twice, 3 times. And we're right back to the screen to where we actually start a program. So now at this point, we're ready to start our new program. So we go New Program, and it asks you for a new program number. And we're going to go 2233. That's the number I picked out. Okay, we're starting the program. Now at this point, the first thing we want to do, we get a right shift, start. The first thing you want to do is define a blank. We select that, and since we're on a machining center, we're not doing round parts anymore. We're going to do a rectangular blank figure. And again, what we're defining here is only for graphics. Most of this has nothing to do with what the actual machining is going to do. This is only for graphics, for the simulation. So we select that, and you got 6 fields that you need to fill out. You have the width, and we're doing a 6 by 6 by 2 inch block of mild steel. So we'll say 6 inch is the width, 6 inch is the length, the height is 2 inches. Now here, this is just for the way you dimension your part. Now when I used to run a mill, when I was trained, we always made the middle of the part be 0, XY 0. So in order to come up with that, the one side will be 3 inches, the other side will be 3 inches, and the top of the part in Z, we're going to say 0.03 30 thousandths, because we want to face off just a little bit off the top of the part. So at that point, we press the Insert Soft key, and it puts that blank in the program. And you can look down here. It tells you what G1902 is. That's a rectangular blank figure. Okay? So at that point, we go to our fixed form, and the start lines, that's what we want to insert first. That has a tool change and everything. And where we had question marks, it comes down and says, imperfect word must be changed. So we arrow up to the first question mark, and it's asking for a tool number. And I know tool number 8 is the one that's our face mill, because we're going to use a face mill first. So 8, arrow over to the D number, which is the cutter compensation number, 8 again. And see, as soon as you do that, with that line over here, it tells you what tool that we've called up. It's a face mill. All right? So then we go down. Now this line, line number 9, it's a positioning move. Again, as we discussed before, this is a line that I always put in. When you're reading the Manual Guide I manual, it will not tell you have to do this, but I always recommend that you do this just so you know where it's going to go at the beginning of the cycle. So it's X0, alter, and Y0, alter. Like I said, that's just a clearance mode. Now this line, again, as we talked about this being a teaching mode, see, it tells you what the G43 is. It's tool length compensation. That calls up the length of the tool. And I always use as a clearance move 1 inch for the Z move. That's 1 inch above the part. And again, the H, that's our tool length compensation number. And again, that's A, alter. And again, the diameter compensation, that's 8 also, alter. And for this tool, we're going to say we're going to run this at 750 RPM. So we put the cursor over the S word, press alter. And again, you always want to maintain, put a feed rate in there just to make it active. So we'll say 10 inches a minute, alter. M8, that will turn on the coolant because we're in a position. Now at this point, we go into our cycles. And what we're going to do first, we're going to do face machining. And it brings us up 2 choices, either rough or finish. And we're only going to make a minimal pass. So we'll go down and say we're going to finish. We'll select that. And again, it's just fill in the blanks just like we did before. And it'll highlight what it's asking for. It says cut depth of radius. That could be a little confusing, but what it really means is what is the step over on that tool when we go from pass to pass. Typically what you do is 1/2 the diameter of the cutter. This is a 3-inch face mill, so we're going to put 1.5, inch and a half. And it asks for a feed rate, a linear feed rate, so that's 50 inches a minute, and 1 inch per minute for the down feed rate. And again, it does highlight what it wants. So we input that. And also, there's detail data, and we'll explain what those are. The cutting method on the face, if you're facing it, you can either have it only cut in one direction, which would be single, or zigzag if you want it to cut both ways. We're going to do zigzag since we're doing it both ways, since it's only a small cut. This is what it does at the end of each cut. You can either have it pull up or stay down on the part. And this is just how it moves to the next cut. If you put 0, it rapids to the next cut. And that's what I put in. The R plane is 100 thousandths, like I always use. The clearance of the axis, that's how far it comes off the part, 0.25. The direction, I said right. You get all these different selections down here, right, left, up, and down. Which direction it shifts. And then just the approach move to start the cut. We're going to say 3 axes. So we've entered in all that information. So we press insert. And now at this point it comes up and says, okay, what kind of figures do you want to do while you're facing? And we're doing a square part, so we select that. And again, it's just fill in the blank. It says what kind of figure type. We're doing a face. The base position is Z0. The center point, we decided that 0 and 0 was our center points in X and Y. We know it's a 6-inch long part and 6 inches in Y. Again, the next two, they have asterisks next to them. You do not have to answer that information. Okay? So we insert that. So those 2 lines of code, that's the XY square that you can see over here. The one before is our facing finish. Those are the only 2 lines of code that we need to do this facing cut. And as we did before, I like to simulate it as we do to go through each cycle. So at this point, we go to Auto, Simlat, Rewind, and Start. So there it milled the face of that part. just cleaned it up. The reason we have this alarm is because we don't have an end of program. So, but it did what we wanted it to do. So at this point, we go to Group Off. We go to Edit. We arrow down to the bottom of the program. So now we got to put another tool change in. So we need to go to a different tool. So we go Fix Form, and the Start Lines again, and we go back in and fill out our data again. So now this time we got to go figure out what tool number is for a chamfer tool, a spot drop. So we got a tool offsets. We arrow over, and see down here on number 7, it's a chamfer tool or a spot drop. So we close, so we know we got to use tool number 7. So we go 7, alter, 7 alter on the diameter. See, as soon as we did that, see now down here it says chamfer tool. So we got the right tool. Again, our positioning move is X0, alter, Y0, alter. Our positioning move to pick up our tool length, again, it's via 1 inch. Again, that's my personal preference. You might want to do something different. I'm all right with that, however you want to do it. 7, alter. 7 alter on our header compensation number. And now for this tool, we're going to run it much faster. We're going to say 3,000 RPM. Just type in the 3,000 as long as you have the cursor over the S word. And press alter. Then a feed rate again, 10 inches, alter. We've done everything to pick up the tool length, start the spindle, turn on the tool. So at this point, we're going to go to another cycle. We go to our cycle soft key, and we're going to do center drawing. We select that, and again, it's fill in the blanks. You got 2 different types. You can either have it normal, where it just cuts in, rapids back out, or you can have a dwell, where if you wanted to make a good round spot, you can do that with a dwell. So we're going to do normal. And then for positioning to start doing these, you can either have initial 1 or initial 2. That would be like if you had clamps or something on the table that you wanted to rise up above, you could do that. But we're going to use a reference position, which is like the R plane. Then it asks for a cut depth, and we're going to go minus 0.375. Our R plane is 0.1. Our feed rate is 25 inches a minute. And our move to start this is a 3-axis move. So we press enter. Now you'll notice as soon as we did that, because that was our cutting condition, then it comes up and says, okay, what are the points that you actually want to spot drop? And you've got all these different selections. Random, linear points, different intervals, grid points, rectangles, circles. So what we want to do right now is a rectangle. We'll select that, and again, it's just fill in the blanks. Our base position in Z is 0. The start point in X is -2 and -2 in Y. Now it says, okay, what's the length for this bolt pattern we're doing in X? So it's 4 inches. And the length in Y is 4 inches also, so we're doing a square. We want 2 holes in each line. And we insert that. And then also, we have another tab up here. You could also have it skip holes if you want. It would be in the same pattern. But we don't want to do that. So we press insert. So there's our rectangle point. But I also know that we want to do a circle, a bolt circle also. So we can do that at the same time. If we go into our figure soft key, we arrow down, and under rectangle we have circle points. So we select that. And again, the base position in Z is 0. Our center point in X and Y is 0 and 0. The radius that we want to do is 1.5. The start point angle is 0, and we want 6 holes. Okay? And again, we have the skip. If we want to skip holes but maintain that pattern, you can do that. But again, it's got asterisks. You don't have to answer that. So we insert that information. And again, like I said, we like to go back and simulate everything we've done. So simulate, rewind, then press start. Okay, goes and faces it. Now it goes and spot drills all those. Very simple, very simple. So now at this point, now we want to drill those holes. Okay, so we go group off, go back to edit, and again, just like we did before, we have to go back to our fix forms and put the start lines in again. And we'll go back up and highlight the T number. Again, we're drilling a hole for a 3/816 tap. So we have our tool offset, so the radius of that tool will be 156.5, 1565, so that's tool number 1. If we arrow over, that's a drill. So we need tool number 1 this time. So 1 halter, 1 halter there. See, as soon as we do that, it comes up, okay, it's a drill. That's what we want. Our position move is 0, and halter in X and Y. Our positioning move in Z is 1 inch. And then it's H1 is our tool length, and B1. Now this tool work, again, we're going to run this at 3,500. We got a good solid carbide drill. And our feed rate is 10. Again, this is just making it active. Again, M8 is turning on coolant. So now we're going to go back. We're going to do a drill cycle. So we get our cycle soft key. Arrow down to drilling. Select that. And again, we got 4 different choices here. We got normal, well, tech, and high speed. Okay? Those are our different selections. For what we're wanting to do here, normal, it will drill all the way to depth and come out. Well, it'll drill depth and then stop. Teching, it'll go into far and do a full retract. High speed, that's for it'll drill so far and stop, like a chip break type. But we won't do pecking. Pecking, cut depth, that's how far it'll go in each cutting move. So we're going to say 0.5. Again, the reference point mode, you got 3 choices. We're going to use the R-plane. Our cut depth is minus 2.5 because we want to make sure it goes all the way through the part. The go past amount, that's still allowed for the angle on the end of the drill, 0.1. The clearance move is 0.1. That's above the part. I always use 0.1. There's our feed rate. And then the positioning move will be a 3-axis move. Then you have detail. Again, it has asterisks here. You don't have to answer all that information. This would be like if you had a big drill where you wanted to start out slowly until it got the drill fully engaged, you can do that. And then also at the end, you could have it slow down at the end. But again, it has an asterisk. You don't have to answer that information. So we insert that. See, as soon as we do that, again, it comes up where it wants us to define the point. But we've already done this before, so we don't need to fill these out again. So we press cancel. And we're going to arrow up to where we just did our pattern, rectangle points, and circle points. So we want to copy those. So we press copy. It says define the range. We want those 2. Copy. Then we arrow down in the program to where we just defined the drill cycle. Press paste. It'll always paste it underneath whatever you have the cursor over. Paste. So it puts those circle points and the rectangle points right after the drilling cycle we just did. So now we can go animate what we just did. We didn't have to fill all that up twice. Send that. Rewind. Start. There's our face mill. There's our spot drill. Now we have a small drill that goes in and drills all the holes, all 10 holes. Okay? And we didn't have to go through and redefine the pattern because we already had that. We just had to copy it and redo it. Let's paste it back in. So at that point, we'll press group off, go back to the edit mode, arrow down to the end. So now at this point, we want to tap the 6 holes in the middle. Okay? So again, we have to go to our fix forms, insert the start lines, and we want to go up to, I know this time it's tool 5 is a tap. So we have 5, halter, alter on that. See, as soon as we do that, it comes up and says it's a tap. I've only got one tap in the tool data, so I know we're correct there. So it's 0 for our positioning move in X and Y. I know we're going over and over again, this over and over again, but it's good practice. Again, our approach point for Z is 1 inch. And the H word, again, that's our tool length compensation, that's 1. And 5, alter. And then 5 and alter on this also. Now on a tap, you're not going to run it as fast, so we're going to say 250. Alter. And then a feed rate, we'll just put 10. Like I said, this is just to make it active. Now we're going to go into a cycle again. Now this time we're going to do tapping. We haven't done this one before yet. Select. And again, it's still in the blanks. You can either do a normal, which would be a right-handed thread. Reverse would be a left-hand thread. We're going to do normal. Floating tap. And like I said, it's a 16-pitch thread. If you wouldn't know what that lead was, you go 1/16. Enter. It does the math for you. So it's 0.0625 lead. The R plane, our cut depth is -1.5. Our clearance is 0.1. No dwell time. And then a 3-axis positioning. Then we press insert. And again, it takes us into where it wants us to define the points again, but we don't have to do that because we want to arrow up. And all we want to do is a circle. This one, the XY circle points. Here. We want to copy that. Only that one. And go down to our tapping cycle and paste. You see it pastes it right after that. So at this point, we can go simulate again. So we go to auto, simlat, rewind, and start. And now at this point, it will go through and simulate all of that. So at that point, it went through and simulated the entire part. We're well on the way to finishing everything we want to do. Okay. Again, we got the end of record alarm. So we go group off. And now at this point, we go back to edit. And again, we got to go to fix forms again and add in our start lines again. And what we want to do this time, we got to mill a pocket in the middle of the part. So again, I think it's tool 2, but I'm not sure. So we got a tool offsets. The arrow over. Number 2 is a flat end mill. That's what we want. So we go look at that, and it's a 1/2 inch diameter flat end mill. That's what I want. So it's 2. So 2. Alter. D2 alter. Again, 0 and X and Y is our positioning move. So we need to change that. The G43Z is 1 inch. And 2 on H, tool length. 2 on the D word. And now this time we're running this pretty fast to 2,000. Alter. Good solid carbide end mill. 10 inches for the feed rate. Do that. Now, we're going to go into a different cycle this time. Another one that we have not done yet. So we go shift, go into cycle. And we've done hole machining, we've done face machining. Now we're going to do pocketing. So we arrow over to that. And we can do pocketing rough. That's what we want to do. We select that. And again, it's fill in the blanks. The first 2 have asterisks next to them. If you don't put anything there, it's going to assume that it's a solid part, like what we have. Or if you're only removing minimal stock, you could tell it how much stock on the sides and on the bottom. But we're not going to do that. Cut depth of radius. Again, this is just like on the facing cycle. It's asking for the step over. We've got a 1/2 inch diameter tool, so we're going to use half of that, 0.25. And if you wanted it to do the math, you could say 0.5 divided by 2. and do the math for you. The cut depth of axes, that's the depth of cut. We're going to go 0.1. We're not going to leave any finish stock. We want to mill it to size. And then the feed rate, we're going to say 25, 25, and 1 inch down. Okay? That's all you need in that tab. You also got detail data. You either got up cut or down cut. This would be like climb cut or conventional cut. I don't know why they don't say that, but that's what it is. The clearance of the axis, that's how far it backs off when it's milling the pocket, how far it backs off the side. I put 20 thousandths. Our hard plane is 0.1. The approach is 3 axes. And we can either have it go straight in or helical in. Either way. I'm just going to say for what we're doing here, to go straight for a 20-degree angle. We insert that. And it comes up and says, okay, what are we going to do here? Well, I want to do an XY circle. Okay? So we select that. And again, it's very simple. It's just fill in the blank. It's a concave, so it's a pocket. The base position is 0. Enter that. The height is minus 0.5. And again, that's one of those where, as you're looking at this drawing, it wants you to put a plus or a minus. If you want it to go down, you got to use a negative. If you don't put a minus, it will assume it's plus. Okay? The center point is 0, X and Y, and the radius is 0.75. Okay? Then we insert that. All right? So at this point, let's go simulate that to make sure it's going to do what we thought we told it to do. Sim that, rewind, and start. So it faces it, hot drills. There's our drilled holes. Now tap all the 6 holes in the middle. Now we got an end mill going through and putting a round pocket in the middle. Okay? So now at this point, we've got that done. We also want to go through and add milling around the outside of it. We can use the same tool because it's big enough, it's strong enough to do that. And what we want to do now is go right shift, in edit, right shift. We want to go cycle. And what we want to do now, we want to do contouring. Outer wall contouring. And we only want to do finishing because we're only going to take minimal stock off the sides. We only want to clean it up. So we select that. And again, it's just fill in the blank. It says, okay, how much stock are you going to take off the outside? We're going to take off 25,000. And we're not going to leave any for a finish pass. And then it asks for feed rates. We're going to say 50 inches a minute for the first tail, then 1 inch on the downward. And the detail data, again, it's either up or down cut. The clearance, the hard plane is 0.1. And we're going to arc on and arc off. So see, it gives you 3 choices. You can either feed down vertically, arc on, or come in at a tangent. So it gives you a lot of choices. So we're going to arc on, 1/4 inch radius at a 45 degree. And then we're going to have a 3-axis move for the approach move. So we insert that. And again, it comes up and says, okay, what are we going to do here? Okay, so this time what we're going to do is we're going to do the square. We'll select that. And again, it's convex. We're going to do around the outside. That's the figure type. Our base position in V is 0. The height, it's a 2-inch part, but we're grabbing hold of it with a vise about 1/8 of an inch, so we're going to go minus 1.875. The center point 0 and 0. The length is 6 minus 0.050. So it does a figuring for you, so it's 5.95. And we're going to put a corner radius on 125. Okay? And the part's in there straight, so we don't have to tilt it. So we insert that. just for those two lines, it'll contour the outside of the part. So we go back to auto, sim that, rewind, and start. Now it should do everything. It should end up like the picture we showed you at the beginning. Drilling all the holes, tapping all the holes, milling the pocket in the middle. Okay, so then it went around the outside. You can see on the corners here, put the radius is like what we wanted. And then also, just to show you what you can also do for the simulation, we're going to rewind. Now this time, you can rotate it around, so we can reverse it. See what that does. It lets you look at it apart from behind to see if the holes drill all the way through. And see that it's going to show the tools on the other side. There's our spot drill. Here comes our drills. See how it's showing that the holes actually drilling all the way through? How you can see the white or drills all the way through. So it's very handy for that. You can see now it's doing the pocket in the middle. And it'll show tool going all the way around the outside. And see how it shows these green lines here? That's showing to where it's just barely cleaning up. So at that point, when we're getting our alarm at the end, we go group off, we go to edit. What we want to do now, we want to add or end a program. So we go right shift and end. And number 4 is our end of program. If we add that, now we've got a full program. So what we want to do now, we're in edit. We go right shift. We want to simulate it again with everything in it. We want to rewind. So what we want to do here is we want to add the time cycle. So you press start. It goes through and does its thing all the way through the program again. Okay. There's it's tapping the holes. Now it's doing the pocket in the middle. Okay. And it does the outside. And there it's done. And then if we go right shift from there, we have a soft key that says insert. And it says machine time data is inserted. Okay. Yes. See, it puts time. If we go into our list and time to make that part, it's currently 8 minutes and 8 seconds. It's got 12 seconds of non-cut time, which is frankly pretty aggressive because, you know, you have to put times in there to tell it how long it takes to do a tool change. But again, you can use it to do time studies also. So now at this point, we've got all that done, and now say we've already cut a part. All right? We're happy with it. It came out the way we wanted. So we say group off. And what we want to do at this point, we want to go to auto, because now we want to convert it to a G-code program. Okay? So do that out of auto. Right shift. NC convert soft key, and 2234 is our new number. Okay, press start. And what it's doing now, it's going through and converting what we just made in conversational into a G-code program. And this program you can take from this machine. If you had other machines with FANUC controls that did not have manual guide I in them, you could take it out of this machine and put it in another machine and run it. Because it's just straight G-code stuff that any FANUC control will read. Okay? We'll see, like right now, it's doing the tech drills. See, it uses a G83 for that. It's just a standard drill cycle for a FANUC control or for a variety of machines. Okay. Now it's getting ready to go through and do the tapping. And on the tapping, it'll just use a G84. You know, that's something that you're used to seeing. So if you'd rather run it off of this, you can do that. And that's what we're doing right now. We're converting this to a G-code program. We'll wait to see it finish. But I just want to briefly show you what the G-code program looks like. Almost done now. It's on the last tool. Okay, so now it's done. If we return out of that and we go to edit, now at this point, we got 2233 was the original. So we go down to 2234. Open that. And then we can page down through it. And what it does, it takes the original conversational cycles and puts those in parentheses, but then it converts everything else to G-code. Okay? And as I said, like in the drilling cycles, it'll use cycles just like what you're used to using. So see, like for the spot drill, it uses a G81, and it tells you what a G81 is and what all the different things in a G81 are. And then also for the where we drill the holes all the way through, it uses a G83. And again, it explains to you what all the different values in a G83 cycle are. So it's very nice for teaching you what the G-codes mean. So at this point, that's everything that I wanted to do today. So at this point, we're going to go back to our presentation, and we'll go back to Mark, and we'll go over any questions you might have. Back to you, Mark.
Okay, thanks, Judy. That was really interesting. That was an informative presentation. In fact, all three parts of the series have been really good, so congratulations. I'm glad I could be a part of this. So we do have some questions from our audience, so we'll get started with those. In the meantime, please feel free to submit your own questions by typing them into the question pane on your control panel at the right of your screen. And we'll get answers for all of your questions, even if we don't get to them while on the air. The webinar is being recorded, and it'll be available online, so if you can't stay for the whole session, you can catch up later. So let's start with our first question here. When I convert the conversational program to a G-code program, how do I adjust cutter comp in the G-code program?
Okay, there is a parameter for if it uses G41 or P42, you can turn on that parameter where it does that. Then you just go into your wear offsets and your tool offsets and adjust it there, whether it, to make it smaller or bigger. So that's how you do that, Mark.
Okay. All right. Another question here is, how do I plunge down when I am milling an outside contour? It seems to only rapid down.
Well, that's where, we just did that on the last cycle. And on it, you have three different choices. You can either have it go down in Z, just straight down, or you can have it come in, arc in, or tangent in. Evidently, it's probably using where it's just coming right straight down in Z, and that's probably the issue. You need to use the arc on and the arc off. So then it'll feed on to the outside contour.
All right. Question here is, can you purchase the desktop version for business use? Did you get that question? I'm not exactly sure.
Yeah, you can, with NC Guide, you can get a version that you can put on a laptop or a desktop where you can actually have manual guide I within it. Yes, it is possible to do that.
Okay. Another question here. With castings, I work above the Z0 quite a bit. How does that work in milling cycles and drilling? Are all Z values absolute, or are some incremental?
Well, with when we do drilling cycles, it asks you for how you want to approach it. There's either initial 1, initial 2, or the R plane. So with the initial 1 and the initial 2, those are incremental values above the part. I think that answers it.
Okay. New question. how does this work with programming a facing head on an HBM, the horizontal boring mill, I'm assuming?
Facing head. I'm not sure what he means by that. What, like doing face milling?
Well, how about
I assume that's what he means, is face milling.
yeah, okay.
Maybe
Maybe it's the horizontal machine.
Yes, yes. Yeah, you can, you can set it up with any type of configuration. It's just that I sort of picked out a vertical machine, but you could set it up like a horizontal also.
Okay.
So it would simulate it just like a horizontal, and there's a lot of different setups that, I mean, because I know on a lot of horizontal boring mills, like you would run the quill out, and that's like a W dimension or W axis. So, but it is capable with manual guide I to set it up with that. But again, that's for our, somewhere down the road for one of our next webinars where we would discuss that. But it is possible to do that.
Okay, good. We've got some more questions here from the audience. Here's the question. Can you speed up or slow down the simulation playback?
Yes, on the newer software, probably on what people are getting on machines today, there is a way that you can slow it up or speed it up. Yes, you can do that. Okay. And obviously on the machine itself, Mark, the simulation will be slower than what it is like on, if you do it on a laptop or a desktop, it's much faster than what it is on the actual control.
Okay, all right. Another attendee's got this question. What is the parameter to turn on the cutter comp?
What is, to be honest, I'm not sure right off the top of my head. But if they send me that question in, I'll get them that answer. I don't know what it is off the top of my head.
Okay, but obviously there is a parameter. I mean, you can do that.
Yes, there is. Because what it does, Mark, just a little bit more explanation of that. Either way that you do it, it looks at the diameter of the tool and the wear offset, but only one of them does it actually turn on a G41 or a G42. You have to turn it on to where it actually puts that in the program. Both ways it cuts it, it still looks at the diameter of the tool.
Okay, good. Got some nice questions here. Another attendee wants to know, wouldn't it be wise to eliminate the D word on drilling and tapping? Now, I'm not sure, maybe you get a better idea what that's asking.
Well, it won't really affect that, because it would only call that into consideration if you were using, if you were contouring with it, because if you're drilling and tapping, you're just going down in one direction. So I don't think it would be an issue.
Okay. Another question. Can you program a Davis head for a horizontal boring mill with manual guide I?
You might have to, I'm not sure if there's parameters to make that work. We could possibly set something up in a fixed form to make it work, Mark. And that's what's good about fixed forms. Things that we can't allow for parameter-wise, sometimes we can put something in a fixed form to make that work.
Okay, good. Some more good questions coming from our audience. Can you edit the fixed format to read whatever you want, right? So instead of changing X and Y to 0 every time on start, just have it automatic?
Yeah. Yes, you could probably do that. Yes. Yep. Make that a fixed point. Yes, you could do that.
All right. All right, let's see here. Is the simulation speed based on speeds and feeds? I guess those are the program speeds and feeds.
Well, when it simulates it and figures out the time cycle, yes, it looks at whatever feed rates you have. But if you slow down the feed rate in the program, it will not slow down the simulation. I think that's what they're asking.
Okay, all right. All right, here's another question. Can you program a thread milling cutter with manual guide I?
Yes. Yes, you can.
Okay.
There is a thread milling feature. Yes.
Okay. Let's see where we got here. How do I make the tool show up during simulation?
Well, that's one of where I have the D word when I do a tool change. If you don't put a value in the geometry for the radius of a tool and then call it up in the program, it won't show a tool. It'll actually show it doing something, but it won't actually show a tool itself. So you have to have a value in the geometry and call it up to that D word in order for it to show it.
All right. How about can you pipe tap in manual guide I?
Yes, yes. Yes, you can. I mean, that's all a matter of, you know, and I've probably the reason they asked that was, you know, a lot of that's based on the type of machine and how powerful it is, how fast you're going to run it. But you need to know the depth to pipe tap, and you obviously have to know the pitch of the threads on your pipe tap, but you're going to know that. So yes, you can pipe tap.
Okay. Another question about threading. Is thread repair a standard feature with manual guide I?
Yes, you have thread repair in manual guide I. However, and you know, this is on a lathe usually.
Yeah.
But
yeah, that's true.
You have to have some ladder support from the builder. We offer it on manual guide I, but if the builder does not put it in the ladder to support thread repair, it won't work. So it's sort of a, you know, it's got both sides have to make it work. We have it on our control. The builder has to make sure his machine supports it.
Yeah, well, I mean, that's pretty typical with conversational programming systems generally, isn't that?
Yes, yeah. It's usually it'll be on there, but the builder has to make sure that their ladder supports that.
Okay, that sounds good. All right, how about, can I do a mirror image?
Yes, you can. Yes, you can. When, especially, there's several different ways of doing it. So, here recently I did it for a customer where we put it in a fixed form. The G51.1 turns it on, G50.1 turns it off, and then you tell it which axes to rotate around. And also, when you go in and draw a free-form shape, there's also a mirror image option there where it does the same thing. So if you did a pocket on one side, then you wanted to just mirror image it on the other side, you could do that. So it's very easy, but you can do that.
All right. Here's another good question I'm glad came from the audience. Can you use a probe with manual guide I?
Yes. There are very powerful probing cycles within manual guide I. And with those, you can use both a tool setting probe mark and also a spindle probe. But it's something that, you know, you just don't, it's a little bit more in-depth setting that up. I mean, you know, it could possibly take you a day to get everything set up for that. So, you know, you have to calibrate the probe and everything like that. It's not something you throw in there and 15 minutes later you're probing. But
but probing has a lot of benefits.
It works very well. Oh, yeah, a lot of benefits.
Sure, probing has a lot of benefits, so it's probably worth the effort for those who can see that. I got a couple more questions here, so I'm going to try to get through these.
Okay.
Do I have to fill in the data for a bolt circle over and over?
No. Just like we did today, what I typically do is, you know, like if you're spot drilling and tapping, you know, once you do it once, you can just go back and paste it in over and over again. So it makes it very quick. And I know today when we went through it seemed like I was doing it slowly, but once you get used to this, you could drill and tap a hole, you can make the whole program in 2 or 3 minutes. I mean, it's very quick.
Okay. Some more questions come in here. Can you set up multiple datums, and can you cut and paste the program for multiple datums?
Yes. Yeah, I guess they'd probably talk about using, like, you know, different, like G54 or G55 or whatever. Yes, you can do that, and then you can just go cut and paste the cycles you want to do at different levels. You could do that. Yes, it is possible to do that.
All right. Another basic question here from the audience. Is the D offset 1/2 the tool? Now, assuming that's the diameter offset, 1/2 the tool diameter.
Yeah, it's the radius of the tool. Yeah, it's
radius, okay.
I know I kept saying diameter, but that's just the way I reference the D word in my mind. I always say diameter, but actually I mean the radius on a mill.
All right, okay. Another question here. You know, a lot of good questions mean it was a good presentation here. I'm always glad to see this. When milling a freeform, can you mill only from point A to point B, or does it have to be a complete box?
It is because there are cycles within the contouring part where it's only a partial contour. So yes, you can just do a straight line. Yes, is the answer.
Okay. All right. I think we can get these last couple questions in. Does the software allow for the size of the tool in the tool table?
Yes, it does. Yes. And that sort of goes back on the question, you know, we answered earlier, Mark, where it was asking about tool nose radius comp. Because what it looks at it, regardless of whether you turn on tool nose radius comp with a G41 or G42, it does look at whatever data you put in your tool offset table. So that's, again, you know, ties into where we talked about it's important that you get the right data in that table.
Yeah. Okay. Good. I'm going to squeeze in one more question here, Jody. How do I make the machine make the tool length active?
Okay, you use that, and we showed that over and over today, but you use a G43. And what that does, you give it a G43 for the move in whatever axes that you're wanting to compensate for. But typically, you'll have G0, G43, Z, 1 inch with an H word. The H word picks up the tool offset, tool length.
Okay. Well, that's always good. Yeah, it's always good to reinforce that point. Okay. Looks like we're about out of time. So, Jody, thanks again for presenting your slides and answering our questions. I think it went really well. You know, for those attending this afternoon session, you can contact FANUC FA America if you'd like more information. Contact information's on the screen. A reminder, if you missed part 1 or part 2 of this 3-part series, you can find it on our website, MMS Online, under the Webinars tab. And we really appreciate the time you've taken with us this afternoon and hope you found it worthwhile. I know I've enjoyed these presentations, so thanks to everyone for taking part. And my thanks also to those who arranged this session and helped it go smoothly. This concludes our webinar. Have a